on a initial value theorem and a final value theorem. The next problem based on initial value theorem and final value theorem. So, in a statement of initial value theorem, in a f of 0 is equal to limit s tends to infinity s into f of s, or here written as limit t tends to 0 into f of 0. So, f of s nothing but Laplace transform of f of t. So, initial value theorem means in a left side is t replaced by f is 0, s replaced by f is infinity. But in final value theorem, limit t tends to infinity f of t is equal to limit s tends to 0 s into f of s. The question is verify initial value theorem and final value theorem for the function f of t is equal to 1 plus e power minus t sin t plus cos t. So, now I first complete the problem is initial value theorem. So, in a proof of initial value theorem, verify initial value theorem. So, t replaced by 0 no. So, question is f of t is equal to 1 plus e power minus t sin t plus of a cos t. So, in LHS t replaced by 0. So, f of 0 is equal to 1 plus e power minus 0 no. E power minus 0 is 1, sin 0 is 0, cos 0 is 1. So, f of 0 value is equal to 2. You verify right side function also a 2. What is the right side? S into f of s no. Before that you find the f of s. So, f of s is nothing but L of y of t or L of f of t. So, f of t L of 1 plus e power minus t sin t plus cos t. Again apply the linearity property. L of 1 plus L of multiply e power minus t into sin t, e power minus t into cos t. L of e power minus t into sin t plus L of e power minus t into of a cos t. So, L of 1 value is 1 by s. Here shifting property and both the second term and third term is apply the shifting property. So, L of sin t, but the final answer s replaced by of a s plus of a 1. Same thing in second also, plus L of cos t s replaced by s plus 1. Suppose here in a e power t means s replaced by s minus of 1. So, 1 by s L of sin t no. So, L of sin a t formula is a divided by s square plus a square. In your question is L of sin t, a replaced by 1. So, next one is the cos a t. L of cos a t is s divided by s square plus of a square. Again the next term also a replaced by 1. So, 1 divided by s square plus 1 squared 1, but s replaced by s plus of 1. The next one is plus s divided by s square plus 1. Final answer s replaced by s plus 1. So, 1 by s plus s plus 1 1 divided by s plus 1 whole square plus 1 plus s plus 1 divided by s plus 1 whole square plus 1. So s into f of s. Apply the limit s tends to infinity. So s now limit s tends to infinity. So 1 by s now s is cancel, only 1 plus s divided by s plus 1 whole square plus 1 plus s into s plus 1 divided by s plus 1 whole square plus 1. So in first sum there is no s term. So you replace the first value, but in second one is numerator is s but denominator is s plus 1 whole square. Now first you rewrite as a second term and a third term. So limit s tends to infinity 1 plus s divided by, here s square, no, s square 1 plus 1 by of s whole square plus 1 by of s square. Plus s, no, s square 1 plus 1 by of s. So here also s square. So 1 plus 1 by s whole square plus 1 by of s square. Cancel the s square term, no? Yes, this one is. So limit s tends to infinity 1 plus 1 by of s into 1 plus 1 by s whole square plus 1 by of s square. S squared is cancelled, 1 by of s divided by 1 plus 1 by of s whole square plus 1 by of s square. So now apply the s tends to infinity, this value is 1, no. Anyway, here 1 by infinity is 0, 1 by infinity is 0, but 1 by infinity is 0, so second term is 0. So 1 by infinity is 0, 1 by infinity is 0, 1 by infinity is 0, remaining is 1, 1 by 1. So 1 by 1 is 1, so 1 plus 1 is equal to 2. So this is in a RHS part of initial value theorem. So LHS also A2, RHS also A2, verified initial value theorem. Verified. Okay, both the value is equal to 2. Same you apply in a final value theorem. Final value theorem means f of infinity, t replaced by infinity, but in a right side is limit s tends to 0, s into f of s. So in this step now this value is f of s. This value is f of s, no. Same thing you multiply by f a s, but s replaced by 0. So now the final value theorem consider for a right side value. Y means already know the f of s now. So final value theorem, limit s tends to 0, s into f of s. So limit s tends to 0, yes, the first term is cancel, yes, 1 plus s divided by s plus 1 whole square plus 1 plus s into s plus 1 divided by s plus 1 whole square plus 1. So s replaced by 0 means vanish for second term and a third term, only for a first term. So answer is equal to 1. So RHS of final value theorem, value is equal to 1. You verify LHS also a 1. So LHS is in initial value theorem, t tends to infinity, that is limit t tends to infinity f of t. What is in your f of t? 1 plus so limit t tends to infinity 1 plus e power minus t sin t plus cos t. So t tends to now e power infinity is infinity. Infinity. So e power minus infinity is 1 by f e power infinity. So 1 by f infinity is equal to 0. E power minus infinity is 0. So this value entire thing is 0, only the first term answer is equal to 1. This is in a LHS of final value theorem. RHS also A1, LHS equal to 1. So verified in a initial value final value theorem. So again one more problem based on final value theorem. The question is verify second question, verify final value theorem for f of t is equal to t squared into e power minus 3t. F of t is equal to t squared into e power minus 3t. Only previous question both verify initial value and final value theorem, but in this question only verify final value theorem. So once again I write the final value theorem statement. Limit t tends to infinity, f of t is equal to limit s tends to 0, s into f of 0. F of s, f of infinity, no. So f of infinity is equal to limit t tends to infinity t squared into e power of minus of 3t. Anyway 0, no, 0 into infinity is 0. LHS equal to 0. So next, before that you find the f of s value. So f of s is nothing but L of f of t. So that is equal to L of t squared into e power minus of 3t. So L of t squared into e power t, finding there are two methods. One is derivative formula, another one is use the shifting property. Shifting property is very easy. Y means here in a L of t squared, but the final answer s replaced by of a s plus of a 3. So L of t power n formula, L of t power n is equal to n factorial divided by s power of n plus of 1. So here n replaced by 2. So L of t squared is equal to 2 factorial divided by s cube. So 2 factorial divided by s cube, s replaced by s plus 3. So 2 factorial divided by s plus 3 whole cube. But multiply by f a s now after you applying s tends to 0. So limit s tends to 0, s into f of s is equal to limit s tends to 0, 2 factorial 2 into s divided by s plus 3 whole square whole cube. So anyway s replaced by 0, numerator and denominator also s term is there, so value is equal to 0. So verified in a LHS equal to of a RHS. The next one more question based on in a final initial value theorem. In the third question, verify the initial value theorem for the function f of t is equal to sin square t. Verify the initial value theorem for the function f of t is equal to sin square t. So statement of initial value theorem is limit t tends to 0, f of t is equal to limit s tends to infinity, s into f of s. So now first find in a RHS part f of s. So f of s is nothing but in L of f of t. F of t replaced by L of sin square t. There is no direct formula for a sin square t. So sin squared you replaced by in lower classes formula, no, trigonometric formula. 1 minus of cos 2t divided by of a 2. I use the linearity property. So 1 by 2 into L of 1. Actually this one is L of 1 by 2. L of 1 by 2 minus of L of cos 2t divided by of a 2. So this one is 1 by 2 into L of 1 minus of 1 by 2 into L of cos 2t. L of 1 is 1 by s. So 1 by 2s minus of 1 by 2 sin cos formula is s divided by s square plus of a 4. S into f of s. So s into f of s, s replaced by infinity. That is limit s tends to infinity. Yes, first 1 by 2 minus 1 by 2 s square divided by s square plus 4. So first s is cancelled, but next one is s square. So 1 by limit s tends to infinity, 1 by 2, 1 by 2, s square is cancelled now. Here taking out denominator is s square. So 1 plus 4 by of s square. S square is cancelled. Now you apply s tends to infinity. So first term is there is no s term, so replace by 1 by 2. But in a second term is 4 by s square infinity. 4 by infinity is 0, 1 by 1, but minus 1 by 2. Anyway, 1 by 2, 1 by 2, answer is 0. So RHS part is answer is 0. So prove that in a LHS also is 0. So LHS is t replaced by 0, no? So limit t tends to 0 into f of a t. In your f of t is limit t tends to of a 0 sin square t. So t replaced by 0, sin 0 is 0, here 0. Otherwise I use the same formula, cos 0 is 1, 1 minus 1 is 0. So verified in a initial value theorem. Okay.